Alright, well our visiting first gen 750 motor here is all finished up and ready to go. It's the one that got the oil filter turned around backwards in it, so it took out the rockers and the cams and some stuff. So that's all redone, and we'll fire it up in a minute so you can see how good it sounds. But one thing I wanted to show, because in order to test one off the bike, you need to set up a wiring harness. Well, I've just been throwing an old harness on there, but I decided finally not to be lazy anymore and get this wiring harness done. So I thought I'd make a video real quick and show how simple just a bare bones harness is that still allows you to have a kill switch as well as charge and do all that, but nothing else is needed for the bike. So let's get the camera set up down here and I'll walk through this little bare bones wiring harness real quick so you can see, because some folks can see them a little easier by looking at the wires than a schematic, and we'll just walk through each one of these wires. Alright, so just what does it take on a bare bones wiring harness to run the motor and also run the charging system and still have a key and a kill switch and a start button like you would on a bike, or if you're going to put it on a go-kart or something like that? Well, here's what we got. So as you can see, this is the rest of the wiring harness, so all that goes away. Bunches of wires you can take off this thing because you don't need all that just to run the motor. So let's start over here with the ground system just to kind of show the grounds, then we'll go through the hot, then the switched hot, and then how it all connects up. So if we're looking at the grounds, what you got, and this is the ground wires coming off the battery. So you got to ground the motor. Of course, it's got to have a ground in order to run the system, but you got to ground the harness and things too. So all the black ones are your ground wires, and if you look, the connections are all connections off the bike, so I didn't take the connectors away, but you can see one ground wire goes to the rectifier in its connector. It's the one that's got the big red hot wire as well. So big black ground wire goes to the rectifier. Then your next ground wire runs over here, and it is actually going to the kill switch. Now this is a kill relay right here, and it is the blue one. And so it's the side stand relay harness part, but it's a blue relay. And don't get confused, they have a little blue dot on them. Some of them aren't the blue relay, some are just like yellow relays or something like that. You got to have a blue relay on the side stand switch connecting harness. So you got a black wire going to it, you got a black wire to that one. Then we're running a ground up to the TCI because it needs a ground. We got a ground coming over to the kill switch because it's what feeds this relay back, and we'll talk about that relay in just a minute. And a ground over there, of course, you have to have a ground wire coming to your start button. So this guy gets a ground wire, you get a ground wire to the kill switch, your regular ground wire to your TCI, the big ground wire going to the rectifier, and then you got to ground the motor. So that's really the grounds for the whole system. So now let's look at the main power and then also the switch 12 volts. So the unswitched 12 volts, and this is 12 volt continuous all the time, you run it straight off the battery and you'll keep your little main fuse that's in the harness, so it'll connect up and it comes back out. Then if you look, the rectifier is powered by constant 12 volts all the time, so it's not switched on this wire, it goes directly to it. So that rectifier is always getting 12 volts even with the key off or the kill switch off or anything like that. The only other place that the main unswitched power wire, 12 volt wire, goes is over to the key. Now that one is the one that controls the fuse and it controls all of the system. When you turn that one on, it comes over here and it powers the brown. So you're going to need a brown and a red off of your key switch on your motorcycle, and that's all you need. The blue one is just for auxiliaries. You could keep it if you wanted to, but it runs red into here, and then brown comes back over. Brown is feeding the rectifier right here. This is the voltage that tells the rectifier to start rectifying and actually holding the charge back for you. The other place the brown wire goes is on up here, and it goes to the fuse box. So once it's switched, that gives you 12 volt switched. Now you're going to run it into the fuse, and the rest of the wiring that's 12 volts switched is going to be fused. So we'll go through the little red and white wires and see where they all go. Alright, so once the brown wire comes out of the switch and it comes up here to the fuse, now it's got a fuse on it. So we got a redundant fuse. This is your main fuse. This is your fuse that's going to run all of your switched power. So the red wire comes down and it comes out and it joins up into the harness. Well, you got a red and white going to the TCI because it needs power. And then you got the red and the whites going to the coils up here. And then they're going to have their control wires coming out of the TCI's connector. So all that's pretty simple. Wires up the same through there. You don't need that other orange wire because it's going to the tack. You just need the one going to the coil. So we got all the red and whites going over there. Then you got a red and a white that comes down here to your kill. And I'll explain that here in just a minute. But it comes down and it connects in the same place for the red and white coming in for here. And then we got a red and a white that's headed out, and it goes over here. Now this connects up to, you probably can't see it in the back, but that connects up to your starter solenoid. So the red and white go to the starter solenoid. The blue one is the one that you're switching. This blue and white, that's the one that you cut on and off, and it's jumping to ground. But the starter solenoid actually has power, keyed power, all the time, and you're actually switching to ground. So then that's all we got for our keyed 12-volt wires. You can see down here to the kill relay, and up here coming out of the fuse box, up to the coils, over to the TCI, and that's where you end that. So now, let's talk a little bit about the kill wire and the little kill relay. Alright, so for the TCI, over here, it's got one wire. It's a black and white. Right here coming down. That black and white wire is the wire that if you ground it, it'll shut off the TCI. And it's used for like neutral and side stand switch and clutch switch and things like that. It's the one that if any of those are active on that safety circuit, it'll kill the TCI, but you'll still have power in your system. You just can't get any spark. It actually grounds this, but this guy is a normally closed relay. That's why it's important that you get the blue relay, because it's normally closed. When the switch is not made, the relay is closed down and it prevents the TCI from sparking. But when you give it power, it actually drops the relay and it makes it open, and then that ungrounds the TCI, so then the TCI can spark. So it actually works backwards. It's a normally closed relay. And you can see down here, the blue and the yellow, I guess it's blue and yellow, coming off of the side stand switch. That is your ground. When you make the switch, that grounds that blue and yellow. The red and the white, that's the key 12 volts. So when you make those two, it switches black, which is your ground, over to the black and white, flops it where it's open in the relay, and it allows the TCI to work. So that's how that old kill switch system works, and it's redundant. You could eliminate all that and just use the key. When you drop the power, it'll drop the TCI, but it's nice to have a kill switch on it, even on a go-kart or something like that, or on a motorcycle where you can turn it off with the kill switch. So other than that, that's pretty much the wiring. You can see the wires stay the same. There's no odd changes in wire colors. You're using your common wires that are in your wiring harness, and so there's no problems there. The TCI, it connects up just like it did before, right up here to the motor. The rectifier connects up using its connector. The starter solenoid connects up using its regular wires, and then you got your fuses and things in place. So there you go. Pretty simple on how to wire one up, and the key can be just a regular 2-pole key. Doesn't have to have a starter or anything like that on it. It's just an on and off switch. So once we got it all wired up and we can see how everything goes with all the different wire colors, then now you can set it up and you can see that your motor will run and it'll charge. So let me get a voltmeter here, and you can see that when I fire the motor up that it charges the whole circuit, all the switches work, and we're good to go for a test setup here for our simplified wiring harness. Alright, so with our multimeter hooked up, and I'll zoom down on that here in just a minute so you can see it's charging. All we do is turn the key on, and you can see we have voltage in our system, so everything's good with the voltage, but it's not going to start because I have the TCI disabled. So when I enable the TCI, now that relay popped in and it'll actually start. So we'll give her a big crank here. I can kill it with the kill switch. Now if the kill switch is down, it's got power to it. Power can go to the starter, so I can actually, like if I wanted to check compression and not have it start, I got the TCI disabled, so it'll actually crank. But it won't start because the TCI is disabled. Or I could start it up. And I could just turn the key off and it kills all the power to the whole system. So there you go. Quick and easy way, very few wires it takes. And I'll draw this out in a schematic maybe so you can see what it looks like on paper. But that's what it looks like in real life with just very minimal wiring, and it's all out of the harness itself. We just got to get rid of a bunch of stuff, and the only thing we kept was the blue relay with the side stand switch connector. The rest of it's just plug and play. Keep only the wires that you need and you can snip off the rest. Well, alrighty. Hope that helps someone, and thanks for watching.